Okay, so once again, good day everyone. So it's just a sort of review of what we have discussed last time or last Tuesday. So last Tuesday, of course, we discussed, our presenters now discuss about the descriptive statistics, no, in a sense that they define the descriptive statistics, which involves the collection, presentation, and analysis of data. And the main goal of descriptive statistics is to summarize and describe the key features of data set. No? And this can be done using various measures of central tendency, such as the mean, median, mode, as well as the measure of variability, such as the range, variance, and standard deviation. Okay? And there are two main types of data, no? As what we discussed last time also, the categorical and numerical. So categorical data is a numeric data that is typically grouped into categories or labels, such as gender or color. On the other hand, numerical data is quantitative data that can be measured and expressed as numbers such as age or weight. On the measure of central tendency, of course, we have analyzing the data set, no, to determine its measure of central tendency. And this measure helps to describe the typical value or behavior of the data set. So, and the three most commonly measures of central tendency are mean, median, and mode. When it comes to measures of variability, no, it describes the spread of dispersion of the data set. So the most common measures of variability is range, variance, and standard deviation. When it comes to data presentation, one of the most important aspects of descriptive statistics is data representation. Data can be presented in various forms, such as tables, no, either charts, or graphs. That choice presentation format depends on the type of data and the purpose of the data analysis. Tables are useful actually for presenting categorical data such as frequency distribution or contingency tables. So charts and graphs are often used to present numerical data such as histograms or scatter plots. No? This visual aids helps to convey the key features of the data set, such as shape, center, and spread. No? So in a measure of central tendency, our presenter give us an example of the mean computation, median, and mode for group and ungrouped data. And I'll appreciate actually, as I mentioned. Then right after that, quantitative methods are a set of statistical and mathematical techniques used to analyze and interpret data, of course. So again, as what we discussed during our last meeting, we discussed about the demonstrate about the range, variance, standard deviation, and so on. So I just want to share again a video presentation wherein you could able to the first one will be the mean, median, and mode. It's just a shorts videos na mga videos, pero it helps you a lot, especially if you are now starting crafting your capstone project. Creating capstone project is not an easy one. So helping with the statistical treatment, or statistical tools, be able to for you to develop your own research or capstone project easier than before. Okay, so I just want to play a video for mean, median, and mode. Then right after that, I just want to summarize again, then proceed to another one.
Hey team, and welcome to the first video in a series on descriptive statistics. My name is Justin Zeltzer, and over the next 12 or so videos, I'll be leading you through every descriptive measure you're ever likely to need. This first video is going to focus on the mean, but you'll find the rest of the series up on zstatistics.com. Now, even though these videos are aimed at beginners, I'd say even statistical veterans will learn something new in each of them as I approach things in an intuitive way and have tried to kind of go beyond the boring definitions of things. But let's not waste your time, let's get stuck straight into it, shall we? Now, the word mean comes from the French mean, from around the 1300s. And originally it was meant to mean the middle of two musical notes. Now, when we're finding the mean from a population, we give it the symbol, the Greek symbol mu. And to calculate the mean, we do the sum of all the observations. This Greek letter sigma here indicates we are to sum all of the x values. So it's the sum of x over the total number of observations, n, which is fairly intuitive. Now, if you're taking the mean from a sample, nothing much happens to that formula, except that we use a lowercase n to represent the number of observations instead of that uppercase N for the population. But we're not going to get too bogged down into populations versus samples in this little video. But if your curiosity gets the better of you, I'll put up a little link here for a video I did on this exact topic. So let's have a look at the mean in action. If you're trying to find the mean of the following sample, 10, 28, 28, 33, and 54, it's as simple as adding them up and dividing by 5 because, of course, there are 5 observations. Now, this is very straightforward, and I imagine most of you would have no problem in carrying out that sum. Turns out it's 30.6, so we'd say that the mean of this sample here is 30.6. Now, as a bit of a convention, you often provide the mean to one more decimal place than the original dataset was given in. So here, because the original dataset was given to no decimal places, I'm providing the mean to one decimal place. Again, that's just a convention, but it seems to be followed by most textbooks and journals and statistical thinkers alike. So good to start getting into some nice statistical habits here, hey? But it's as simple as that. Now, for the advanced section of this video, I've got 3 little extra pieces we're going to have a look at. Firstly, I'll try my hand at calculating a weighted mean. I'll then look at a special case where we try to find the mean of a categorical variable. And finally, I'll offer you a challenge question, which I'll ask you to answer for me in the comments of this video. Or at least you can big up anyone that's got in there before you with the correct answer. So to introduce this, let's take another look at the sample we just used. So there's our 10, 28, 28, 33, and 54. Another way of describing this dataset is to put it into a table form like this, where I've got x in one column. These are all our values of our variable x. That's 10, 28, 33, and 54. And then I provide f of x, or in this case we can say the frequency of x, in this second column. So that's 1, 2, 1, and 1. And notice that, of course, the sum of all these frequencies is going to equal 5, the number of observations. So the reason why I'm showing you both of these side by side is to get across the idea that the weighted mean is so intuitive and you almost don't need a formula for it. If you've watched any of my videos before, you'll know how reticent I am to just provide a formula and say, just use that. That's not really my way. I like to make things intuitive, so let me have a go at doing this. In the initial example, what we did was we summed up all the observations and divided by 5. But of course, you can probably recognize that 2 of these values are 28. So without even worrying about what a weighted mean is, we could have known to just, well, let's times 28 by 2 and then add it to all the other numbers. Doesn't really change anything, does it? But in writing it like that, you can see that we've effectively, on the numerator here, weighted each of the observations by the frequency that they occur. So 10 is multiplied by 1 because there's only one 10. 28 is multiplied by 2. 33 is multiplied by 1, etc. And then we divide by the total number of observations, or alternatively, you can consider that the total number of weights. So in other words, if you were to see a formula that looks like this, yeah, that looks pretty ugly, but it should be quite intuitive, right? You're multiplying all the values of x by their frequencies and summing them up, and then dividing by the sum of all the frequencies. So it's quite literally what we are doing in this formula above here. And I guess I wanted to show it to you this way because I wanted you to appreciate that a weighted mean is actually nothing special. At the end of the day, a regular mean is just a weighted mean where all the weights are 1, right? So a weighted mean's really no different, just as a fancy formula. Now, as promised, let's have a look and see if we can find the mean of a categorical data set. So here we have one that I've created, which is just male or female. Let's just say this is a litter of dogs. And we want to find the mean sex of the dogs. Is that even a question you can ask? Doesn't sound right, does it? But is it possible to find the mean of this data set? Well, not as written, but say we define all the females as 1s and all the males as 0s, we now have a numerical data set for which we can find the mean. So again, that's quite straightforward. I just add up all of those values and divide by 6 in this case. It looks like there are 4 females and 2 males. So this calculation becomes 4 on 6, or 0.66666666. Now, what do you think that represents? Well, in this case, because it's a binary variable, that's a categorical variable with just 2 options, the mean is actually the proportion of the category that we defined as 1. So this represents the proportion of females in this litter of dogs, if you'd like. So a mean of a binary variable actually gives you the proportion. Now, I wouldn't get too much cuter than that. I wouldn't try to apply a mean to a categorical variable with more than 2 values. It certainly wouldn't make sense in that case. But in the binary case, it certainly does. Okay, so are you ready for your challenge question? Here we go. Calculate Georgia's weighted average mark that she's got from her statistics degree thus far. She's done 4 subjects, and here are her marks. And these are the credit points that the subjects are each worth. So if you're going to try to calculate her weighted average mark, you're obviously going to have to incorporate that information. Once you've done that, feel free to post up your answer in the comments, or at least big up someone else that's got in there before you and got the correct answer. And if you like these videos, feel free to check out the rest of them on zstatistics.com, or click through to the recommended video, which will hopefully be the median, or a cheeky. Hi team, Justin Zeltzer here from zstatistics.com with an extended look at the statistical concept of the mean. Now, I've started referring to the mean as the cheeseburger of descriptive stats, in that while it's pretty plain, ultimately it's very dependable. But if you think you know all about the mean and you're about to skip this video, I'd suggest not, because there's some interesting stuff I do here looking at things like geometric means, harmonic means, and I also offer you a pretty difficult challenge question. I tried to think of the toughest question I could about the mean, and I came up with something that I think you might find quite challenging, and I'm going to pose it to you to put your answers in the comments. So even if you think you're an expert on the mean and you know how to add things up and divide by n, come with me on a little journey here, and you might find some stuff quite interesting. Now, the earliest reference to the word mean comes from the 1300s, from the French. I'm going to guess that's pronounced mean. But someone that's French could tell me it's just pronounced mean, maybe. I don't know. But it's a term that's been around for a long time, and initially it was used to describe the middle point in between 2 musical notes. And we'll see that pops up a bit later when we talk about harmonic means. Anyway, the basics are to the end of year 3 will get us to 100 good about the mean. And I came up with something that I think you might find quite challenging, and I'm going to pose it to you to put your answers in the comments. So even if you think you're an expert on the mean and you know how to add things up and divide by n, Come with me on a little journey here, and you might find some stuff quite interesting. Now, the earliest reference to the word mean comes from the 1300s, from the French. I'm going to guess that's pronounced mean. But someone that's French could tell me it's just pronounced mean, maybe. I don't know.
Take Centrum Silver Advance at 50+.